Hey everyone, welcome back to the channel. You're watching our cloud school. In this video, we are going to talk about Terraform infrastructure testing with Azure Key Vault. So we'll have a Azure Key Vault module, which you can see on my screen. So this is the module we have, which is here for provisioning a Key Vault resource. So I've just copied this Key Vault resource block directly from Terraform documentation and did some slight modification, like I've added these variables like key vault name, location, and rest of the settings are pretty much same. But consider that this is a key vault module which I have it in my project, and this is going to provision a key vault resource. You can have a key vault module in your case which can produce one or many key vaults. That's not a problem. Now this key vault requires these three variables for an example. So I have declared those variables here in my variable.tf file, and then once the key vault module provision the resource, it returns the output as in certain variables like resource id as an id, name as in name with an output parameter, and then as an output we have a location which is represented by the key vault location in which the key vault has been deployed. Then apart from that, I'm returning whether the key vault has got the public access enabled or not. So based on these, I'm going to write my validations in the test case. Based on this information, I'm going to write the validation in my Terraform test cases. Now to define the Terraform test cases, we have created a directory inside the module itself. So if this is my key vault directory or key vault module, so inside the key vault module I have created a directory called test, and inside this directory we have our test file which is written with Golang, and that is the reason the file syntax is .go. So if I open this main underscore test.go file, you will find that I have a bunch of line of code, and the very first line we have is we are declaring a package, and the package name we are giving it as in test. Now after that we have certain number of imports. So what we are doing with these imports, basically we are going to utilize some of these libraries which are being already available as part of the Go language, and then there are some third-party libraries which are developed by, let's say, Stretcher and then TerraGrunt to support our Terraform testing. After these modules, we have a constant which is declared, and we are calling the constant name as in fixture, and fixture is basically representing or having the value of the directory where we have our actual module place, which is one level up, which is here. Next we have the number of variables which we have declared, which we may be using some of them into our Terraform test cases. So the variables, like we have the global backend configuration, then global environment configuration, unique ID, then expected name of the key vault, expected location of the key vault, so that I will compare this expected versus actual. Then here is the code or the function which is basically commented out in case if you would like to use some of the environment variables within your Terraform test case. Before I move further, just to let you know, I'm going to check in this code into my GitHub repository, and the link I'll be sharing it into a description of my video, so you can find this code anytime. And in this code I have the test cases for the key vault, test case for the resource group as storage account, and going forward in future we'll be placing the test case for many modules which are related to Azure. Okay, moving further, we have at line number 45 we are declaring a type, and we are calling a type as in test condition, which is going to be of type integer, and that type itself we are using inside the constant block. So with this type we are declaring certain number of constants. So the type as in test condition equals, so this basically we are creating a kind of a enumeration, if you understand, which is of type this, and then we are assigning the value to the enumeration, let's say 0 for test condition equals test condition not empty for 1, and then test condition contains for value 2. So these are my enumeration values which I'll be using it going forward in whenever I'm going to have my assert in place. Moving forward, I have a function basically which is defining my Terraform options, or basically Terraform configurations, which will help running the test cases to run the Terraform initialization, Terraform plan and apply command. So what configuration it has in the options method. So here we have function to pointer, which is basically using the Terraform dot option. This Terraform is coming from directly from this particular import block. So we are using a Terragrunts Terraform class or Terraform object, and in this object we have the option, and then option has various number of parameters like Terraform directory, which is coming from our variable which we have declared above. Then you have the variable files. So I am going to use a variable files with this Terraform. If you don't want to use the variable file, you can declare the inline variables with like this, which is commented right now because I'm using the variable file, though you can use both variable file as well as the variable like we know. So having this variable file in case in place, my Terraform is whenever my Terraform is going to run, it will use this variable configuration, which means that it will use this test variable file, and in this variable file I have the resource group which is having this value, location which is having this value, and then the key vault name which is having this value. So whenever the Terraform will run, it will use this configuration as a variable file, and then environment variable. In case if you would like to use an environment variable, you can use it, right? There are some additional parameters which are also there, such as no color configurations and some other configuration or the other parameters which you can use like backend config and all. Moving forward, you have your actual test case method, so which is declared as in function, and then the name of the method is test underscore automation, and then the method type is expecting a function pointer argument which is coming from the testing, which is basically coming from this particular module, right? Now here in my testing block, first thing to note here is your test method should always define with a keyword test as in prefix. If you do not declare the method name as in test prefix, then it's going to be not considered as in test method, and whenever you will run the Terraform command to execute the test cases, or whenever you run the Go language commands to execute the test cases, the method will be ignored and Go language will not found any test cases to execute at all. So it is really important that whichever method you would require to write it as a test method, it has to be prefixed with test. Just to simplify that, I have added the underscore, but underscore is totally optional. You may or may not want to use the underscore, but test is something which is absolutely necessary. Next is inside the method line number 79, we are specifying that the test method should run in parallel. So I'm going to use the test.parallel so that it will run all those test cases in parallel. So basically the execution will run obviously in single run, because we are just targeting a single module, so it will run single-handedly by creating the particular object in the target environment. But the evaluation or the comparison of the assert values can run in parallel, or in case if your module contains the provision of multiple resources. For example, your module is creating, let's say, virtual machine or Azure Key Vault, and there are some additional resources which it is trying to create, then in that case this parallel is going to be very, very helpful, right? Moving on, we have the Terraform module dot method. We are using the init and apply and idempotency, which means that whenever this automation method is going to be executed as a test method, first of all it will run the Terraform init and apply as an idempotent, which means that only a single run at a time will be applicable. If somebody is trying to execute another run, then that run will be rejected. Next we have the default keyword, and then default keyword we are using terraform.destroy. Having this in place, obviously we would like to destroy our infrastructure once our test cases are executed. But this deferred keyword means even though our test cases evaluation, our assert conditions are failed, or even there are any errors in the code due to some reason, then having defer in place, we always want to execute the destroy command, which means that no matter what happens, whether your Terraform assert works or not, or your test case assert works or not, you always wants to run the destroy. The reason for that is you want to delete your resources as soon as you finish your test cases, no matter whether test cases are pass or fail, so that you're not provisioning the resources unnecessary by running these test cases, and then the client or the owner of the subscription is getting paid for those resources which are hanging because of these test cases run, right? Next we have the important line, where in line number 92 we are calling a run object or run method, and inside the run object we are making call to a method which is a output validation. That is where this is a method in which we are going to have all our assert which will be validating against this particular test execution. So remember, from this test method we are making a call to the output validation method, which is basically going to have all our asserts. So to define or to implement the assert, what we are doing inside this method, which is having the body starting from line number 96, we have a structure declared, and the structure name we have given it as in test cases, and this structure having this body. So structure has got an attribute which is of name and type string. Then next attribute, it has got the name as in got and then type as a string. Next it has got want and the type is a string, and then we have a next and the final attribute name as in condition, but this time the type we are using the enumeration or the constant which we have declared at the top. Remember, this is the constant type which we have declared. Now this type is having these three constant or the enumeration values for an understanding. Now once this structure is declared, what we are saying next is we are defining or we are initializing this structure, which is a test structure, with these two test cases. The test case number one, the resource name matching, that is the name of the test case. So what we are saying here is we would like to match the expected name of a resource versus the actual name of the resource. So for that, what we are doing is we are retrieving the output which has been returned by the Terraform apply command, and then we are going to compare with this expected name, and the compare condition is going to be the test equal condition. Let me just minimize. Test condition equals, that is the enumeration or the constant we are going to use. Next element in the structure is going to be the next test case. So every element, if you look at here, is representing one test cases which is required to be asserted by your code. So first test case is going to be evaluating the name. Next test case is going to be, let's say, location, right? Matching. So we are going to compare the location, what is expected versus actual. So you could write any number of test cases one after other inside this particular test case structure. Basically it is type of array, as you can see from line number 97. And then once your array of structure is ready with all your test cases, what we are doing here is we are running a iterative loop which is a for loop with a golang on this structure. And within this structure, what we are doing is we are calling a run method, and within the run method we have a switch case, right? And in the switch case we are using this condition object, condition type, which is this type, and this attribute which is condition object. First attribute, whatever value you pass as in your test case, which condition you want to evaluate as in test case. So here in the first case I have mentioned that this is the condition I want to evaluate, which means that whenever the first element of the structure is going to be iterated, it will use this condition, it will fall under this switch case, and it will run this assert. If you have next condition as in, let's say, condition test condition not empty, which means if you would like to use assert not empty condition, then you may want to pass your fourth argument as in test condition not empty. If you would like to test any kind of a contains method with your assert, then in that case your test case should have the fourth argument as in this particular constant value, right? So having these values in place, I could have any number of test cases like I mentioned, and then your for each loop will execute all of your test case conditions against this switch case condition, and it will evaluate whether the cases are matching and your test cases are going to be succeeded or not. So let me just run the condition. To run the test cases, I am going to click on the test method or the Golang file, and I'm simply going to open an integrated terminal, and I'll simply run the test cases. Before you run the test cases, as I'm running the test cases on my local machine, so I need to authenticate myself into the Azure environment on which I am trying to run these test cases. But if you are trying to run these test cases from the automation, then you know how your Terraform is supposed to be authenticated from the automation point of view, like using the service principal and all, right? Now, before I run that, let me just show you how I did or how do I run that. So I'm going to use the Terraform account command and then show commands just to make sure that I'm logged into a particular Azure account, and that is what the result I'm expecting, right? I'm going to clear the terminal again, and then the very first command we have to run is the go command, which is going to be go mod initialize, and then you have to give the what module you would like to give as an initialization. So I've called it as an test mod. You want to call it anything, you can say test, you can call it as a test Terraform, or whatever you want name of your module you want to give as an initialize command, you can give that particular name. So as soon as you run this command, what will happen is you would see that it is going to create go.mod file, and if you open this command, you would find that there is a module which has been declared with this name, whatever name you have given, and it's going to use the Golang version, which is 1.21.0. Next, it is saying that you need to run the go mod tidy command. So what will happen with this is it's going to download all the required module which you have mentioned as in the import command. So let me just show you again. So here at the top import section, whatever modules I have mentioned that this needs to be imported, so it will import all the modules plus the dependent module. For example, if the random module is depending upon something else or Terraform module is depending upon something else, it will download all the modules. Let me show you how it will work or look like. So let's run this command. That will create another file in the same test directory. Of course, we are not supposed to check in these files like .go.mod and the other file which is going to be created. That file are not supposed to be checked in. As I mentioned, the tidy command is basically trying to find the module which we have mentioned in the import block, and it's trying to fetch those modules from the source location, which is in this case some of the modules it is trying to fetch from the GitHub, and this process will take time, maybe a couple of seconds or a minute approx. So I'm going to pause the video and wait for the command to be finished. So tidy command is finished. It has taken quite a lot of time, like 27 seconds it has taken. 4 minutes 27 seconds it has taken. Now next command is going to be, let me just clean up the terminal before I run the next command. So next command is going to be go test, and then we have to run the timeout. Because I'm running the Terraform test cases with Golang on my local machine, sometimes it takes time to provision the resources and then validating those resources and then finally destroying the resources. The default timeout for running the go test command is 10 minutes. So if any of your resources takes or any of your entire cycle takes more than 10 minutes, your test cases are actually going to fail. So it is really important you give a timeout higher than the default timeout, which is 10 minutes. So in this case, I've given the timeout with timeout, and then the value in minutes, like 30 minutes, m for minute. And then finally I'm using the tag v. So v is going to find out your test case or the test method actually, and it's going to evaluate all your test cases. If you do not use the v, then it will run the Terraform code, but it will not run all the asserts which you have mentioned in the code. So try running the Terraform test command without v. You will see the result in the difference, and with v, and you will figure it out what is the difference, right? So let me just run the command as it is. Like, so it will take a couple of minutes maybe to run the entire cycle. Like, it will initialize, it will run, generate the plan, and then apply, and then perform the assertions, and then finally again run the plan, and then destroy. So the command is successfully initialized the Terraform, as you can see from the console window, and it has also generated this .terraform directory. Though we are running the command here, but as in the path we have mentioned one level up, so it's basically running all the Terraform command at this module, and it has basically generated the Terraform initialization directory here. And the initialization is successfully completed. Now next command it is running is the Terraform apply command, with input as in the variable file which we have given in the configuration, as you can see here. As expected, it's running the Terraform apply with this changes, which shows that it's going to create a resource, add new resource, which is going to be creating the key vault, and as an output it will generate the resource ID, location, and the name, which will be using it in our assert. So the resource is successfully created, and we have got the result as an apply complete, one resource added, 0 change, 0 destroyed, and this is what our output is. And now finally it's going to run the next command, which is going to be Terraform destroy. And so next command is going to run is Terraform plan, just to make sure that there are no changes, subsequent changes afterwards. So here it has run the test cases, as we can see. It's running these 2 test cases, and after that it's again refreshing it by, because it, and after that finally it wants to run the Terraform destroy command again with the same variable file, so that it can destroy the resources, and then finally it will display the result. So test case is completed, and as expected it has got result, and you can see that the result has got these 2 test cases which we have mentioned in our code configuration. And after the running the test cases, we can see that it has successfully provisioned the key vault as a resource. Then after that it has validated the resource attributes, and then after successfully validation it has destroyed the resources. And that is what we need from our infrastructure automation test case, right? So that's it in this particular demo. So just for the information, all the changes or the code which we have discussed in this particular demonstration, you can find the code here in this GitHub repository. Link I'll be sharing in the description of this video. You can find the code, and you can modify your module the way you want to. You can add the additional code or the test cases in this particular block, and you would be able to use this code as is to test your key vault module, resource group module, and storage account module as well. In future I'll be publishing some more other modules test code with Azure and Terraform. Till then, do consider subscribing to the channel if you haven't already. Thanks for watching it. See you in the next video.